All right, perfect. So thank you everyone for joining in for our first session for our A2L Technical Training Day. I'm here joined by Michael deSouza and Lee Martindale from Mitsubishi Electric Sales Canada, and they're going to be speaking on the reasons for the A2L transition. So I'll do a quick introduction. So Lee Martindale has nearly 15 years of experience managing HVAC service and installation teams at leading companies. And over the past 4 years, Lee has led the technical support teams at Elevate Home Services and Mitsubishi Electric, bringing extensive leadership and industry expertise to every role. Michael deSouza has over 10 years of HVAC experience in commercial and residential applications. Since he joined Mitsubishi Electric in 2021, Michael has served as a residential HVAC M&P Series technical service specialist, and he's been responsible for handling warranty claims, quality assurance, and training. So without further ado, Michael, Lee, take it away.
Okay, guys, I'm going to allow Mike to get into the presentation in a minute. I'll be keeping an eye on the chat if there's any questions. I do see somebody saying that they're not hearing anything. I don't know if Francesco can help with that. And then I'll be assisting with the questions after.
So sorry, Lee, I'm just going to jump in really quickly. Yeah, so I'll be monitoring the chat as well. If anyone's having any troubles, always just like usual, a simple refresh of the page normally helps do the trick, because I know I've seen other people saying that it works fine. So if anyone else is having issues, we'll be monitoring the chat as well. And I forgot to mention as well, if anyone has any questions specific for this session, post them in the chat, and we will be keeping an eye for the very end of the session where we have a Q&A panel, or a session, I should say. So sorry for interrupting, but just wanted to let everyone know about that.
Yeah, no, perfect. Thank you, Francesco. So like I mentioned, we'll do some questions at the end. That's where I'll assist Mike, and let's get into it. I'll let Mike deSouza move forward here.
Hi, everyone. Thank you for joining. Thank you for Plumbing and HVAC for allowing us to share some information with you all today. Today, we'll be talking about, the new topics of, A2L refrigerant, specifically, Mitsubishi Electric residential A2L heat pumps. So what we'll be covering today is we'll do a brief introduction. I'll just show you how, who I am. Lee Martindale, he's already introduced himself. We'll talk about some of the A2L safety requirements, safeties and the requirements, product installation and application, things that are pertaining to A2L sides of today. And then specifically multi-split systems with Mitsubishi. On branch box applications, there are going to be some additional A2L changes there, so we'll cover that. And then, of course, since we are moving into new product lines and A2L products, we have made some enhancements to it as well, so we like to touch on that. And then our training and resources, ways for you to learn more about our products, and also if you need to get in contact with us, I do provide our emails there. So if there's any questions today, we're happy to answer them. But if there's anything else after today's session, please feel free to give us an email. And then at the end, of course, some questions for those who may have some. I won't be covering this slide because Francesco has already covered this. But just to give you guys an idea, I've been doing commercial HVAC mostly for about 10 years since I joined here, covering residential product in technical services. I have been doing warranty claims, quality assurance, and training. So if there are questions that you may have specifically about these things, warranty claims, quality assurance, and training, I'm happy to answer those, but I think those would be best in an email form. All right, so let's get into it. A2L refrigerants, safety, efficiency, and environmental impact. Why are we making the change to A2L refrigerants? Well, there has been a new mandate, which we need to have new refrigerants with lower global warming potential. So specifically the R410A GWP, global warming potential, was 2088. The new R454B refrigerant, which will be used on Mitsubishi Electric equipment, has a global warming potential of 466. So we are below the new threshold, which is really great to hear. Obviously, the environment is really important to all manufacturers. So having a new global warming potential, a lower global warming potential, is a really positive move in the right direction. Now, these new refrigerants, which are classified as A2L refrigerants, are considered by ASHRAE as mildly flammable. They do have low toxicity, and of course, the positive is the global warming potential is reduced. So, since they are classified as an A2L refrigerant, this equipment must utilize a refrigerant detection system, an RDS system, as per the UL 60335 2-40. So there are some changes to the equipment when you are dealing with A2L equipment, with additional sensing mechanism built inside the indoor coil. Additionally, there will be some mitigation actions which aren't related to refrigerant sensors, and that could either be activation of fans, indoor fans, to disrupt the air in the indoor zone. There could be pump down features, which would be pumping down refrigerant to the outdoor unit, which we do have an application where that is a mitigation method. We'll talk about that later in the presentation as well. Some of the attributes of R454B, they are near azeotropic refrigerant blend, HFC HFO blend. It is a mixture of 134 and also R32. Less refrigerant is needed when you're comparing it to a system charge when you're dealing with R410A and 454B. So there will be less refrigerant needed at the outdoor unit or pre-charge from factory, which is a benefit, and I'll explain in the next slides. Better energy improvements, better heat transfer. So in general, the new A2L refrigerants and 454B specifically, it's designed for a balanced performance, safety considerations, and obviously a less environment impact. On the right here, we do have a PT chart. So just to give us kind of a reference and compare the pressure temperatures to some previous refrigerants and also the newer refrigerants, R454B and R32 on the right there. When we look at it and we see it compared to an R410A system, we see the refrigerant pressures are generally pretty close and familiar for technicians and design purposes. So there isn't too much of, at least for me, not too much of a concern there. As we can see, R22, when we made the jump from R22 to 410A, the pressures were were much greater. So there was that learning curve. So I'm confident that 454B will be a smoother transition going into the A2L refrigerants. Now, because these are classified as mildly flammable, there is a lower flammability limit which needs to be considered. So there has to be a proper dispersal volume to keep the refrigerant concentrations below this LFL, the lower flammability limit. And the reason for this is we want to prevent the accumulation of refrigeration in the case of, or increasing the risk of ignition on flammable refrigerant vapors. So these limitations vary. It could depend on the room size, the type of system, a ducted or versus a ducted system, ductless or ductless system, I apologize. Equipment location, and then obviously manufacturer requirements or recommendations as well. So we'll talk about all these points throughout the slide. Some mitigation strategies, which I mentioned, there will be refrigerant sensors and alarms, so audible alarms, error codes, sensors at the indoor unit to detect the refrigerant in the event of a leak. There may be considerations such as permanent space ventilation. That would be more of an application design type of specification. Continuous airflow, blower operation, or momentary mitigation airflow to disrupt the air, as mentioned before. And then, of course, there's automatic refrigerant pump down systems with isolation valves, and we'll talk about that on one of our specific products. Now, refrigerant application requirements. Although not all systems may require a sensor, there always is the consideration to not to have the total charge of refrigerant below the LFL. So how we look at that from a manufacturer's perspective is we need to size the room to take measurement of the room, and then see if the refrigerant charge in the event of a leak would fall below the LFL. So as an example, on this slide here, we have a 100 square foot room. We cannot have a system which would contain more than 5 pounds and 4 ounces of refrigerant. This would be for a non multi-split system, a branch box system, so a one-to-one system. Although there may not be a sensor, we still have to be cognizant of the room sizes when installing these, so that there isn't any risk of flammability. A2L refrigerant sensors, as per the UL Underwriters Laboratory requirements, all air handler units must have refrigerant leak sensors. So a ducted system, which we do have in our catalog. For Mitsubishi Electric Systems, the need for refrigerant sensors will depend on the configuration. So single versus a multi-split system, and then of course the ducted, as I mentioned, will always have a refrigerant sensor. We do offer ducted and ductless system. On a one-to-one wall mount system, there will be no refrigerant sensor needed. However, the previous chart where we cannot exceed the lower flammability limit would still need to be considered anytime we are sizing or selecting an install location for one of these equipment. So could be a little bit of a learning curve. Some of the things that we have to educate as we go through the transition to ensure that we don't exceed these limitations and these requirements, standard requirements. On other ductless systems, there will be refrigerant sensors included in the box. However, wall mount ductless systems, since the risk is not there, the sensors are not included in a box. However, on branch box systems where there must be installed, the branch box will include sensors in the packaging and does require field installation. Some more about the sensors. We do have an example shown here. So this is where we would have a ductless indoor unit, which on a one-to-one, so an outdoor unit connected to a single zone indoor unit, that would not have a sensor installed with the unit or is not included with the unit. However, in a branch box installation where you must install a sensor, one of these on the left side of the screen, one of these sensors will be included in the packaging. You must remove the front box assembly of the indoor unit panel and then install this sensor. As you can see, it's connected to a wire that's already chased through the indoor unit, and then connected and proceeding with the installation. Extra sensors are included in the box. So, for example, in a 5-port branch box unit, you may only use 3 ports, so there would be an additional 2 sensors. The recommendation is any sensors need to be sealed in a plastic bag. They can be one-time use sensors. So depending on the exposure, parts per million of refrigerant that it's detecting, it may exceed the limit threshold where it will not be deemed reusable. So any sensors that are given extra in the packaging, it is most beneficial to store these in dry places in a Ziploc bag or a plastic sealed bag for any time you may have a malfunctioning sensor. Sensor location at the indoor unit, it does vary. So the idea with the sensor is that it is placed in an area where there's most likely for it to be refrigerant accumulating at the indoor unit. So generally the refrigerant is heavier, so it'll like to drop in a low point at the unit. So what that means for us is the native location on an air handler unit, such as you see here on the screen, it on a vertical installation, the sensor is on the left side at a location where there's most likely to be refrigerant accumulating. However, on indoor units, which can be reconfigured to allow airflow from horizontal or downflow, the sensor must be relocated in order for the sensor to be sensing most accurately in the event of a leak. So another transition, kind of step that we must go through is, always being aware that refrigerant, where it's likely to accumulate, and if we're going to reconfigure any of the indoor units, we must be following the guidelines the manufacturers is recommending to sense refrigerant at the most likely source. Additional error codes for Mitsubishi specifically. We have refrigerant leak error codes. We have sensor error codes. We have an error code which will say that the system is in a refrigerant leak. However, that might not be the indoor unit that is detecting the refrigerant. It'll still notify the end user that there is a leak in the system. On units which do not have a wall-mounted unit, the unit will provide an audible sound, so a beeping noise at the indoor unit, as well as a flash sequence at the indoor unit. On units which have a wall mount controller, the end user would be presented with an error code. Additionally, there will be an audible alarm, so a beeping noise coming from the wall mount controller to notify the occupant that the system does detect refrigerant at one of the indoor units. So now that we learned about the sensors and now that we learned about the error codes, how does the system respond in the event of a leak? So the indoor unit, which would be detecting the refrigerant at the sensor, that is only where the sensors are located at the indoor units, would sense that there is refrigerant. It'll send that information to the outdoor unit. That information received by the outdoor unit, and it now begin the mitigation process. So at the indoor unit, you will either have an error code or you'll have a flash and beeping sequence occurring. It'll then perform its air circulation or air mitigation. What that means is the fan would be turning on to a high speed, circulating the air within the space to disrupt any refrigerant accumulation, therefore reducing the risk of flammability. So that's happening at the indoor unit. The outdoor unit will stop the compressor and shut down the system. So again, some additional steps with educating our users on how the system is going to react in these events. Unit installation, location, and placement definition is really important. An indoor unit can be installed in either a conditioned space or an unconditioned space. The parameters that meet these conditions is if it's an unconditioned space, there would be no supplier return. And that is important for us when we're looking at more of equipment selection or design, which I'll give you an example here on the next slides here. So this is something that can be common in maybe a multi-functioning residential building where you have more than one suite and you can have mechanical rooms on each floor with an air handler and a mechanical room or a closet. The maximum charge for a 15 square foot room, which we can see here, the mechanical room is placed in a 15-foot square room, which is an unconditioned space, is £1. So typically £1 is not, it'll be difficult to select a system with £1 of refrigerant to allow this unit to be installed there without posing a risk. So in a scenario like this, there is methods such as adding louvers or pass-throughs to increase the square footage. So if we were to add a louver and pass through to this mechanical room, we can be utilizing the corridor, the kitchen, our kitchen 6, and living room 5 space. We can show you an example of a method that could be used. where we have louvers and pass-throughs, similar to what you may see in a furnace room where you need to have a pass-through to comply with a TSSA gas code. This is where you would want to have considerations for levers and pass-through. So one lever at the bottom would need to be above 7.8 inches from the floor, and 50% of this louver or pass-through needs to be above the 7.8 threshold. Additionally, there would need to be an additional pass-through 4.4 feet 11 inches, 5 feet if we're rounding up, another pass-through above that. So something like this, as you can see as an example shown here. Again, this is just an example, and we must always follow local building codes, but these are some of the methods that we are seeing moving forward with the new refrigerants. There are additional A2L refrigerant identifications at any port where you are going to be connecting either a manifold hose, so service manifold, or the refrigerant pipes, line sets between the indoor and outdoor unit, or for service work. There is these snap tags, these red tags at these points to notify the contractor, installer, or tech person that you are now dealing with a A2L refrigerant, a flammable refrigerant. So it's a warning for us. I kind of like this. I wish it was something that was used when transitioning from R22 to 410A, where you can have a clear indicator you're dealing with a different refrigerant. So it's used for safety, but I really like having this here as a kind of a little identifier, so that you're dealing with a different refrigerant, whether it's A2L or if it's flammable or not. I think it's a really nice feature. Installation requirements. There are additional tags at the indoor and outdoor unit where we must, as a manufacturer, are recommending this. At least I can't speak for other manufacturers, but we must put the date of first charge on the tag, and then we are labeling the additional refrigerant. So we see here on the left, we have rows 1, 2, and 3. We would be putting on rows number 1 would be the factory charge, number 2 would be the additional charge, and then 3 we'd put the total charge there. Okay, so as much information we can put on the system to know that the right amount of refrigerant was installed there, so that if we need to ever go back to ensure that if the space is meeting the lower flammability limits, we can always go back and see if there has been additional charge to ensure everyone's safety. We can go back to these. Installation on branch box. Branch boxes are, well, let me take a step back. On Mitsubishi, we do have 2 styles of multi-split systems, or multi-zone systems, in 2 configurations. One is considered as a ported. That is where we have one outdoor unit, and each line set or each zone is going from the outdoor unit to the indoor zone. On branch box applications, we have an outdoor unit connected to a branch box inside the home, and each indoor zone or each indoor head would have its line set routed through from the branch box to the indoor unit. Generally, the branch box systems are larger or does contain more refrigerant, so there is additional A2L considerations that we must make note of. Now, branch boxes can be installed in 2 different placements. So one would be considered a non-living space, which would be behind a ceiling or inside a wall, which would not apply to the chart that you see on the right. However, commonly we may have a branch box installed in a living space, which would then need to follow, which would be considered as an indoor head. Therefore, we must ensure that we are still adhering to the lower flammability charts. And you can see here on the right here, if we can see the square footage of a room, and we need to ensure that we are below the total weight of the system. That will ensure in the event of a leak at the branch box, should there be one, that it would impose as a risk. So again, flammability is a really hot topic with A2L refrigerant. So we always have to make sure we're doing our part to ensure safety. Now, on a system with on a branch box multi-split system, you will have a different behavior in the event of a leak than you would versus a single or a ported style system, the MXZ ported style system. In those indoor units on the ported or single zone, there is no sensor, so there really isn't any mitigation action or risk. The only risk would be to ensure that the space can handle that refrigerant in the event of a leak. However, at the top of the screen, you see the branch box PUMI. This is where we have some additional safeties, and we'll talk about it through these next few slides. So in the event of a leak, you will have the beeping or flashing, depending on the type of system, and the indoor unit will enter a high fan speed for approximately 380 minutes. So you have beeping, error code will be presented, and then fan operation to disrupt the refrigerant. So the PUMI outdoor unit, which can be connected to Mitsubishi M&P series via the branch box, it will have these indoor unit mitigation actions, but since they do contain more refrigerant on M&P series systems, there needs to be additional safeties, and these safeties are a pump down system, which in the event of a leak would send the refrigerant to the outdoor unit, pumping it down safely in order to reduce any risks. So there may be a situation where we would need to be disabling sensors during startup sequences because error codes can trigger or false error codes can trigger sensors to activate, or the pump down mitigation action to engage. An example for this would be an error code. So if a communication error code. So on a startup, it's more likely where there could be a communication error code just due to the commissioning. So there may be situations where we'd want to disable the sensor during those commissioning steps there to avoid any false mitigation actions or pump down sequences to occur, which is creating a nuisance for installations and time. So there could be scenarios like that where we'd want to use those, but generally we always want to keep the dip switches engaged. At any time, if it's being disabled, it must be returning to that initial state as well. So these are the shutoff valves at the outdoor unit. So our 450 PUMI outdoor unit do have these automatic shutoff valves on the gas and liquid sides. And the reason for this is that we can increase the minimum room area to allow the flexibility for when we are designing or selecting these products. So it gives us the ability to increase the minimum room size, allowing a little more flexibility. Now these shutoff valves are on the outdoor units. They are always they are engaged when the power is off, and that is a UL requirement. So when the power is off to the system, these valves would be in a closed position. This is just showing the sequence of a refrigerant in the recovery mode. So if we work through the chart, we see that there is indoor unit B is sensing the refrigerant that is leaking at the sensor. The system will move into cooling mode regardless of which mode that it's in. It'll close the liquid side, shut off the valve. All the indoor units would begin a mitigation process, which would be the air circulation to disrupt the refrigerant, reducing any risk and hazards. It'll continue pumping down. Once that the pump down is finished, it'll close the gas side of the valve and the compressor will stop, and that'll be the end of the refrigerant recovery. On a more of a positive note, since we had the opportunity of transitioning to new systems, new refrigerants, we had the ability of making some enhancements to our product. So kind of on, just ending it off on a more lighter mood. There is a new indoor unit design, as you can see here. We have an FX model, a GX model, slightly redesigned. Different material is being used. It's a matte white finish. So, depending on aesthetics and preferences, there is those changes. There is Wi-Fi compatibility, or we do have at least the Wi-Fi built into the indoor units now. Without now support for the Wi-Fi availability may or may not be available at this point, but there is that future compatibility, which we are really impressed or really happy to have. Additionally, just based on the new refrigerant properties, we are able to get some improved heating performances. So on an FX unit, currently the 100% heating capacity, which you see on the top right there, that unit on top right, it is 100% down to minus 23.3. So another positive, and this is a lot to do with the new refrigerant properties. There's a new remote controller design, new wall mount controller, and also that wall mount controller does have that audible refrigerant leak alarm. So that is a good feedback for anyone with any concerns or maybe hesitancy with the new refrigerant. The system has all the features to ensure that everyone is safe. On select indoor units, there is an improved dry mode, which is another really positive, worth mentioning. So that'll be on the new refrigerant. Now, on our technical training, so if you do want to learn more about Mitsubishi Electric products and A2L transition, we do host service and installation training. These are hosted regularly at our distribution offices. So that is across Canada. And if you want to, learn more about A2L, you can always, you're welcome to join us. You do need to do some online prerequisite training in order to come into the courses in class sessions, that is. And that is done through our MESCA Academy. So we have lots of our additional learning through our MESCA Academy website. So is that something you'd like to have access to, there is ways to go through the distribution network to gain access. On our A2L content on our website, so to find literature on existing product, we use the Mitsubishi techinfo.ca website. That's where we have all of our Mitsubishi product manuals. A2L product manuals are not available there just yet. They will be coming shortly. So if you do need to get additional A2L information, product specific information, please come and check that website in the near future. They'll be posted there shortly. If you'd like to find a dealer near you, there is a where to buy feature on our Mitsubishi Electric corporate website, which is www.mitsubishielectric.ca. My email and Lee's email. So if there's any questions that you may have after today's presentation, or if you're going to be watching this on YouTube on record, you can send us an email at michael.desouza@mesca.com and then Lee Martindale at mesca.ca. Thank you all for joining today. Hope I was able to answer any questions that you've had about Mitsubishi A2L refrigerant in general. If there's any questions that you have, please feel free to ask me or my colleague, Lee Martindale.
Perfect. Thank you, Michael. And yeah, we definitely do have some questions that were going on along in the chat. We definitely had some good ones. So I'm just going to bring it back a little bit. I think you kind of did touch on it, which in one of your slides, but I'm just going to kind of read what the chat was saying, and then you can have some additional input if you'd like to have from there too. So pull up the questions. So I think the first one was when you were talking about size requirements. So it was pretty early. I think it was either like the third or fourth slide. So regarding size requirements, we had a question come in from Victor Hyman. He said, does that mean that the furnace room needs to be greater than 100 square feet when installing a centrally ducted system? We then had 2 additional responses, one from Mark Thompson asking, I thought room volume was the determining factor, not square footage. And then Victor also added in responding saying, does the room size requirement mean that mechanical closets can no longer be used to hold the air handler? Now, I know you also went into this a little bit more later on in your presentation, but did you have any additional thoughts, or did you have any additional responses with regard to this specific exchange?
Well, so my understanding, I believe, now I'm not the perfect expert, so I will try to answer the best of my ability, and hopefully we can have a discussion and continue figuring these things out together as we transition. I believe it's the room volume which we must be considering in a mechanical room. That would be something that would still need to adhere to the space requirements. So the minimum area available in that space would need to not exceed that charge threshold.
Okay, perfect. And Lee, I don't know if you had anything, if you wanted to jump in with that as well too.
Yeah, I mean, we do have the ability to, like Mike said in the one slide there, with the cut-ins in the doors, similar to what we see when we make up for a smaller room with combustion air for natural gas. We do have that as well, as long as all the rules are followed that go along with it.
Okay, perfect. Okay, so then we had so bear with me. There was a little bit. There's quite a few replies to this specific question. So I'll just read it all just to add the context, and then we can have a further discussion from there as well too. So the initial, the first response, or the first question, I should say, came from Lee K, and they asked, why as an industry do we need all of these mitigation requirements for A2L mildly flammable refrigerants, but don't require this for the natural gas or propane used to heat most homes in North America? Significantly more flammable than our refrigerants. We also then had a response from Victor who added, maybe because the refrigerant has no odor, while NG and LP have Ripitan added. Lee then responded saying, all right, that makes sense. Thank you. Then we had also additional dialogue from James, who added, I would think it's more to do with the liquid propane or vapor propane, which then prompted a response from Charles, who added in saying, makes a little sense to me. If it is odor, just add artificial odor to the refrigerants, same as to natural gas, which then James followed up with liquid propane expands 270 times the volume when released, and vapor doesn't, and all propane in a house is vapor, not liquid. So that's the full context of some of the replies that we're having. I don't know if you guys had any additional thoughts or responses on that.
Lee, did you have anything?
Yeah, I mean, it's hard for us to know exactly why. Like, they raised a lot of good points, and there's many different factors. You're right. Like, I mean, it's heavier than air. It's, there's not the mercaptan in it yet. The why of this, why this is, we can kind of speculate a little bit, but I would imagine it's a number of these different factors that these guys are speaking about that play into the reason why they've chosen to do, leak mitigation mandates on this equipment.
Mm-hmm.
Mm-hmm.
And then we also, sorry, Michael, were you going to say had anything?
I think just the classification alone, the A2L classification by ASHRAE, since it's classified as A2L, which is there has to be new requirements as per the UL standards, right? So it's classified as that. Obviously, the cause and the effect is there is additional things that need to be done to ensure that the safety is there. So the reasons, exactly as Lee mentioned, there could vary why they do it.
Perfect. So we also had another question coming in from Breyer. He asked, do you know when to expect the A2L units available in the Ottawa area? So I don't know if maybe any of you guys have specific information regarding that, or maybe point him in the right direction.
They will be here sometime in 2025.
Okay, yeah. Perfect. And then we also had an additional question from Maxime. He asked, any differences between US and Canada or in between provinces on specs and A2L safety features?
Safety features, with respect to Mitsubishi Electric, I believe there likely will not be. Sorry, the second part was there was the question was?
Yeah, so the question as it read was, any differences between US and Canada or in between provinces on specs and A2L safety features? So I don't know if maybe Maxime maybe wants to add in as well, maybe add a little bit more clarification and to add maybe additional, but just reading off of that's exactly what the question was.
Okay. Yeah, as with respect to across provinces with specifications, no, there isn't any changes or differences. Now, with respect to like mitigation methods, there could be local building codes that you must comply with. So there's always the factor of the local codes, which we always have to make sure. So there could be some differences between that. So always follow local codes.
All right. Well, it seems like your response was good because Maxime responded saying the response was good. So there you go. You nailed the response.
Excellent.
And then Breyer also responded saying thank you for answering his first question. And then he also added, when will A2Ls be required in Canada?
Ooh, okay. Maybe I'll pass that on to Lee.
Well, required. So it's required's a funny way to put it, but we'll have to say all manufacturers will need to, there'll be a sell through of R410A equipment. So most manufacturers will be bringing in A2L this calendar year, and will be selling through the 410A. So there's not any really hard dates as far as how long we could sell 410A. We just can't bring any more of that in. And then there will be an announcement coming shortly regarding the commercial sector for next year. Like similarly, what they're dealing with in the USA, they are about a year ahead of us on all this process.
Perfect. So that's up to date right now with all the questions. We still have about 18 minutes left. So if anyone has any additional questions or maybe wants to bring up any specific information regarding some of Michael's slides as well too, maybe have a further discussion as well. In the time being, I guess maybe Michael, Lee, is there anything additional that you guys would like to add on to with regard to this discussion? Maybe get into a little bit more nitty gritty of some things maybe that we didn't get to discuss as thoroughly in the presentation. Is there anything that comes to mind?
One thing quickly is that there's lots of new recommendations that are coming out regarding tools and whatnot with A2L refrigerants. So I would definitely be following, like for us, we've went through and we've done the HRI course on A2L, just kind of prepare ourselves. And so there are some new tools out there and whatnot, brushless motors on reclaimers and vacuum pumps. Right now, it doesn't seem to be a mandate. It's more of a recommendation. So just as we approach this, if guys are in the market of having to update some old tools or whatnot, just be aware of that and possibly update your tools to something that's going to be completely safe to work with A2L refrigerants. So that was one thing that's came up a few times.
Mm-hmm.
Yeah. One thing that I would also like to add is if anyone would like to learn more about A2L refrigerants, similar to the ozone depletion certification through HRAI, they do offer an A2L training course, which I did take, and a few other our colleagues at Mitsubishi Electric did take. So it was a helpful training session. They do touch on specific refrigerant requirements similar to what we talked on today, but as Lee mentioned, recommendations for brushless tools, things like that. The tanks are left-handed thread, so there would need to be those adapters as well. So it is a really good resource using the HRAI website. It's a trusted resource as well. I did have a chance to speak with an HRAI rep at the Heat Pump Symposium earlier this week. That A2L refrigerant training course is not mandatory currently, but it could be something that could happen in the future. It's not in the plans currently, but that's good information available for all of those who need to get that.
Perfect. And just wanted to quickly bring up, we did have some more responses going on in the chat, which we really appreciate. I've been loving to see all the comments and the discussions going on. So just touching on, it's more so of an added response to what, Lee, you were talking about with the compatible tools. Maxime said, Brushless motors is a key word when discussing A2L compatible tools. We also then had some questions. The first one being from Lee, again, who thank you again for your comment. They added, why are some going R32 and others to R454B? And then they added on saying, is R454B not going to get hit when the GWP number goes to 500 max in 2030?
Just based on the information that I have, so the GWP of R454B is below 500. So it is lower than R32, which might have been a reason why some manufacturers decided to go with 454B versus 32. At least this is, just kind of my speculation, not in any information that I received. But if, let's say, the threshold were to drop down even lower, if it were to be above 500, then 454B would still be, usable, which would be nice. So I think maybe that is a reason for choosing certain refrigerants versus another.
Mm-hmm. Okay, perfect. And then we also had another question coming in from, and I hope I pronounced your first name correctly, Anatoly. They asked, do I need to get recertified if I already have an R410A MEC certification?
Sorry, what was the certification that he listed?
MEQ certification.
For 410A, Mike. So no, we encourage everybody to get out and do our new trainings that will be kind of evolving as everybody gets more experience with A2L. But no, if you have a current valid 410A a current valid MEQ certificate that was done on while 410A equipment was prevalent, that will still apply as we make this transition. But we do encourage everybody, this fall especially, to check out their distributors, see our schedule, and get out to an A2L class, as we've already been incorporating A2L into our trainings. But like I said, as we get our hands on this equipment, as we get more feedback from our friends in the United States, we're incorporating more and more A2L content into our training.
All right, and then did you have anything else to add, Michael?
Yeah, it's because it was a good question and something that I didn't talk about in the training. So this MEQ training, which is the training that we do provide to our contractors, just to add to what Lee said, this training does not only educate the contractor so that they can install our equipment specifically, better, or the way that we like to see it done. It also allows for additional or allows the product to be registered for its extended warranty. So another added bonus when you do come in for our training. We love to have as many people at our training as we can. So anything we can do to get more people to attend, we'd love to have you there.
Okay, perfect. Now, we have one question, and it's also a scenario that was asked by Eric. So I'm going to read through it. So the scenario is, we are in cooling. Leak is sensed on multi-system indoor with insulation valves, liquid line closes, compressor runs, and then the gas line closes, compressor stops. Is there risk that air can be sucked into the system where the leak is? How does the unit know when to stop the compressor when pumping circuit out? Now, before you add on to that, we had another response in from Anatoly, who said, based on manufacturer testing, 9,300 sec of pump down mode will not allow air in the system. So I don't know if you guys had any additional thoughts or comments on that scenario.
Yeah, no, that's exactly it. So there was that question we've had, but based on the time that's given, the risk is low or not there. That's why it was chosen for that length.
Okay, perfect. Lee, is there anything else to add on to that, or is that pretty much something?
No, that's pretty much that. That's the way it was designed, and that's the way that the timing that was set based on the testing they've done to reduce any chance of that happening.
Perfect. And then we just had some additional follow-ups with regarding the specific refrigerant talk. Sorry, I should say. We just had some people. Don was talking about, I believe, in specific with regard to the refrigerant R454B. Don added, it runs with a different POE oil. And then Leah, who plumbing HVAC editor right there. She added in with also some additional information saying that that specific refrigerant does have a GWP of 466. And she got that information from Kemmers, who will be speaking later on in our session. So a little bit plug as well, too, for another session going on in our event. Just looking through. We also have another question coming in from Lee, very active in the chat. I love this. This is perfect. I love it. So I'm going to read through it as well. Lee adds, in Ontario, contractors need to acquire a manufacturer certificate from a training session on the A2L refrigerants if they plan to register to offer the heat pump rebates to consumers in Ontario. And it needs to be done for all manufacturers. You plan to promote and install. Getting lots of questions around this as a wholesaler these days, though I would put it out there. So I guess it's kind of more, just more of a discussion point as well, too. I don't know if you had any additional information onto that or yeah, I'm not too sure.
No, I don't have anything to add on that last comment. No.
Okay.
Yeah.
So the other comment here below I see from Leah Den, according to the Mitsubishi Electric website, GWP R32 is 675.
Okay, perfect. Yeah.
Yeah. So that I had only the GWP for the 454B, so 675 does sound about right off memory.
Perfect. All right. So yeah, we have still about 8 minutes left. If I know we've had a lot of discussion going on as well in the chat, which has been really great. If anyone has any additional questions, any additional thoughts or comments, if they want to add in, please do so now, as we still have a little bit of time as well.
Yeah, and just as a reminder, if there are any questions that you do have, maybe it doesn't come to you now, I'm happy to answer as much, as many emails as you wish. So please do not hesitate to contact me through my email.
Mm-hmm. And if you give me 1 second, I'm actually going to add in your guys' email in the chat as well here too, just so it saves you guys the trouble. So I'm sending in Michael's email right now, and then I'm going to add in Lee's as well too. So just give me 1 second for that. Okay, perfect. So yeah, in the chat, you guys have both those emails as well. Like Michael said, if you want to, send some questions their way as well too. And again, like we said, this presentation is going to be posted on our YouTube and our Training Trades website, and then the presentation will be featured as a written article in our magazine. So again, if more discussions, if you have any thoughts when you're watching this over or you're reading the article, if you have any questions, stuff like that, keep an eye out for these emails, and then maybe you can reach out to them and have a little bit more of a dialogue regarding some of the thoughts or questions you guys had.
Right.
Perfect. Okay, so yeah, I think we may have tapped out all the questions, which is not a bad thing because we did have quite a few responses. So I'll give it another minute or so just to see if anyone else has any other thoughts or questions coming in. Don was just adding in saying, great job, guys. So I'll give it more to you guys. Good job for the session as well, for Michael, the presentation, and Lee for helping out with the comments and some of the replies as well, too. And I guess then quickly before we go, I know, Michael, you mentioned that there's training going on. Do you know if there's any additional ones that are coming up in the near future, like within the next, couple weeks or months? Like, do you know that off the top of your head, or should they just refer back to the website to kind of get additional information onto that?
Well, the best way to find upcoming training is to contact our distributors. On our website, we do have our distributors listed there, so they can reach out directly to find out about training. If they're already registered on our MESCA Academy website, they can log in and they can see a list of training dates that are upcoming. Off the top of my head, I believe we do have one at our Ontario distributor, which is MitsAir in Mississauga, on May 26th, I believe. Okay. We also do have a session or a few sessions happening in Ottawa, which I believe is May 21 and 22nd off the top of my head. So if you're in Ottawa region and you want to, get some training, you'd reach out to the distributor there, Deagle there, and they'll be able to set you up.
Perfect. I think that one's going to be specifically, if I remember correctly, Briar. He had the question about the units be available in Ottawa region. So that one specifically could be for Briar right there as well too. So yeah, I think we got 5 minutes, but I think it's okay to wrap up a little bit early so people, can start heading over to the next session that we have. Again, thank you, Michael, and thank you, Lee, so much for this presentation. I think it was very informative. And the biggest thing, obviously, the presentation was great, but the discussion that we've been having in the chat as well, too, the dialogue, this is what we look to see for all our sessions. So please keep that same energy for the next sessions that we have going on as well, too. So right as we sign off, the next session is going to be held by David Kim from LG, and it's going to be on the fundamentals of A2L refrigerants, safety, system design, compliance, and applications. So as soon as we stop this broadcast, you guys will be able to head over to that one and start getting ready. That one's going to begin at 1:05. So again, Michael, Lee, thank you so much for taking the time to present with us today. And thank you, everyone, for sitting in on this session.
Okay. Thank you, everybody. Have a good day.
Thanks, everyone. Thanks for putting this together. Plumbing and HVAC, appreciate it.
Oh, we appreciate that as well, too. All right. See you guys in the next session.
See ya.